Lecture problem 4. A stone is thrown vertically downward with an initial speed of 4.90 meters per second from the top of a building that is 19.6 meters high. Determine A, the velocity of the stone just before it strikes the ground, and B, the time that it takes the stone in the air. Clearly, this question is a one-dimensional kinematics question, and to be more precise, it is a free-fall question. As agreed upon in this class, we use the positive direction of the vertical axis to point straight up. Because of that, the initial velocity of the stone, which is launched straight down, must have a negative component. The initial speed is given in the question to equal 4.90 meters per second, but the component of the initial velocity is negative 4.90 meters per second. The other thing that I usually do is to set up the point where objects are launched to be the origin of my system coordinate. Therefore, this point here, which represents y0, is going to equal 0. As a result, the position of the stone at the moment just before it hits the ground is equal to negative 19.6 meters. If the 0y is set up to be the top of the building, any point below that must be negative. Write down that information on the side here. Y equals negative 19.6 meters. And as we all know, the gravity has a value equals to 9.8 meters per second squared, and it is always pointing straight down. Since the time t is not an important factor in this question, at least for now, the best equation that can help us to find the velocity just before the object strikes the ground is that one that is time independent. The v squared final equals the v initial squared plus 2 times negative g times y minus y0. Notice that the y is known to us as well as the y0. Substituting for the known quantities, the final velocity is what we're looking for, v squared. The initial velocity is equal to negative 4.90, make sure you square it, plus 2 times negative 9.8. The y is equal to negative 19.6, that's important, minus the initial y, which is equal to 0. Solving for the velocity, you obtain two possible values from the mathematics standpoint. v1 equals to positive 20.2 meters per second, and v2 equals negative 20.2 meters per second. Since the stone at the moment just before it strikes the ground is pointing straight down, therefore the acceptable answer is negative 20.2 meters per second. The positive answer is not an acceptable answer. Now that we have solved for the velocity just before the object strikes the ground, it is very simple to solve for the time. Any one of those kinematics equations that are time dependent can solve for the time. But the simplest of all is the one that relates the velocity to the time. The v final equals v naught plus negative g times the time t. Substituting for the final velocity to be negative 20.2, that's very important, the negative sign, equals the initial velocity, which is also important to be negative, 4.90 plus negative 9.8 times the time t. Solving for the time t, we obtain 1.56 seconds.